Well, if you guys have made it this far, we are at the end of our Math 12 video lessons. So I don't know about you, but I feel good about that. So we have covered the entire course. We got through it all. We did leave a little bit out actually here and there, but you can say you finished, pretty much all of it considering the conditions. Anyway, so hope you guys are doing well, and this will be our last video. Sad. Okay, so I'm just going to really wrap this up with the conics section. We've covered ellipses, parabolas, circles, and hyperbolas, and a little bit on linear functions. And today I just want to just quickly go over some review material and hopefully keep this pretty short. So anyway, it's been great teaching you guys. I know I really wish, well, I wish we had been able to finish it off at school actually, but here we go. So the formula you see in front of you, this is the general form of a conics type equation. And so right now, we don't really know what shape this would be other than it's supposed to be one of the conics shapes. So there's a few conditions we can place on the coefficients, and the coefficients here are the A, the C, the D, the E, and the F. And let's see if you guys can guess what kind of conics shape we're talking about here. Okay, so I'm gonna turn that off. And here, do you want to switch tablet mode? What is going on? What does that mean? Let's try that again. Oh, my OneNote closed down. Okay, I'm going to pause this. Okay, try that again, see if this works. Okay, there we go. So here's our general form of the conic shape. And so once again, we have circles, parabolas, ellipses, and hyperbolas. And so let's say that you know that the A and C, when you multiply them together, they give you a number that's bigger than 0. And you're told that the A value is the same as the C value. So this type of condition restricts the general form to be only one of the one of the conical shapes, I should say. So I'm going to write all 4 conditions down. I want to see if you can match them. Or if you maybe just take a sec, see if you can match them match the conic shapes to these conditions. So let's say you're told that A is equal to 0 or the C value equals 0, but not both. Or the A value and the C value, when you multiply them, gives you a number that's bigger than 0. And the A value does not equal the C value. So it's not the same number. And then the last condition will say that the A and C, the product of A and C, is a number that's less than 0, so it's a negative number. And that is that A and C would have to have opposite signs. Okay, so let's write an equation down. So we'll just see if you guys agree with this. So I'm going to create a question where the A and C is bigger than 0, and the A value equals the C value. So let's say you had something like let's try 5x squared plus 5y squared equal, let's say, I don't know, 20. Okay, so there's an example where the A and C give you a number bigger than 0, and the A and C equal each other. And then maybe for the next one, let's say the A and C, the A equals 0 or the C equals 0. Well, if the A equals 0, then you would get, let's say, so if A equals 0, if the a equals 0, and the c then can't because it's one or the other, but not both. So that means you'd have something like y squared plus 2x plus 3y minus 1 maybe equals 0. Or if the c value equals 0, then the y squared would be gone, and maybe you'd have x squared plus 3x minus 2y plus 1 equals 0. And for a and c being bigger than 0, so being positive, and the a does not equal the c, then I guess we would have like maybe 4x squared plus 10y squared equals, let's say, I don't know, 20. Keep it kind of like the first one. And then the a and c are less than 0, which what that means is one of the numbers is positive, and then the other number would be negative. Something like those examples there. Well, for the first one, if we were to divide both sides by 5, that would give us x squared plus y squared equals 4. And that looks an awful lot like a circle. So I think that would be a circle. So, circle. Next equation, well, if you only have an x squared or a y squared, so only one of the terms is squared, well, that's characteristic of a parabolic function. So this would have to be a parabola. And then if a and c give us a product that's positive, then they're either both positive numbers or both negative numbers, and the a cannot equal the c. So if I divided both sides by 20, I would get x squared over 5 plus y squared over 2. Now I would want to graph that. That's definitely an ellipse. It's an elliptical shape. And if you had AC being less than 0, I guess you probably guessed by now this would be a hyperbola. And once again, I wouldn't want to graph this hyperbola, but I wouldn't make you graph something like that because that's pretty tough to graph. Okay, so there are some conditions of the conical shapes. And if you want to just do a little bit of review on this just for your test, page 385, so page 385 to 386, it really goes over a lot of all the stuff we've covered in a really sort of concise way, all the review of that material. So I want to finish off with one question just that we have to complete the square on. And I want you to look at it and think, what shape would this be? Think just given the criteria we've just covered here. Once again, once you know the shape, I want you to find some properties out about it. So if you think it's a circle, then find the radius and the diameter in the center. If you think it's an ellipse, find the major axis, the minor axis, where the foci are. If you think it's a hyperbola, try to find the length of the converse and transverse and conjugate. Transverse and conjugate axes, where the foci are, the equation of the asymptotes. And if you think it's a parabola, then maybe find the vertex, the directrix, and the axis of symmetry. So those are all kind of questions I would ask you on this. But I'm not going to tell you what shape it is. I want you guys to see if you could figure out what shape this is. And the one thing I will tell you is that this is not in standard form. This is in general form. This is kind of in the form we wrote up the top there. Okay, so take a look at that. You guys decide first of all what shape it is, and then I want you to complete the square on it, and then decide all the properties that you could find out about it. So if you could just pause the video for a second, think of this as your last classroom question here. Okie dokie. So I'm going to complete the square by rearranging my terms a bit. So 4x squared plus 8x minus y squared minus 4y is equal to positive 4. Okay, so I'm just going to rearrange it to group my x terms and my y terms together. Now you could have put y at the beginning or not. I kind of like it where it is now because I see it being negative, and that's kind of making me think this is most likely going to be a hyperbola. Okay, so let's factor out a 4 from the beginning. So that's going to give us x squared plus 2x plus some number. And then factor the -1 out. And you don't have to put the -1. I'm going to take it out just to make sure we don't miss that. That's going to be y squared plus 4y plus some number is equal to 4 plus some number plus some number. Okay, so let's take a look here. So we factored that out. Let's divide 2 by 2 and square it, which gives us 1. And now let's take 4, divide that by 2, which is 2, and square it, and that gives us 4. Okay, now it kind of looks like we added 5. If you just look at the green numbers, it looks like we added 5 to the left-hand side, but we really didn't, because the 1 is being multiplied by this 4, so we actually added 4 to the left side, so we'll add 4 to the right side. And the other 4 is being multiplied by -1, so I have to add -4. So -1 times 4 is -4. Okay, so that works out quite nice. That's going to give us 4x plus 1 squared minus, now I'm going to get rid of the -1 now because I think it's clear that's a negative. That's going to be y plus 2 squared equals 4 plus 4 minus 4 is 4. And now divide everything by 4 because we want that to be a 1. So x plus 1 squared minus y plus 2 squared equals 1, but this is over 4. So we're dividing everything by 4. Okay, so we know it's a hyperbola, so that's already been determined. So I'll just find out some of the properties of the hyperbola just to see if you guys agree with this. So let's find the center. That's probably the best thing. And I think we want to find h, which is -1 in this case, k, which is -2. So we now know the center should be at -1, comma, -2. So it went left 1, down 2. Now the a squared value, so a squared, is the number under the positive term. So that would be a 1. So the a value is 1. And the b squared value is the number underneath the negative term. So that's 4. So the b value would be 2 then. So we have all the numbers we need, except for maybe c. We might need c to determine something else. But let's just keep working here. So we know the center is -1, comma, -2. What else might be asked? How long is the transverse axes? How long is the conjugate axes? Well, the transverse axis is 2a, so that would be 2. And the conjugate axis is 2b, so that would be 4. What about the equation of the asymptotes? Let's say slope of the asymptotes first. Slope first. Slope of the asymptotes. Well, slope is rise over run. So I'm going to look at the y value, which is a 4. By square root, it gives me 2. So looking at this number here. So the square root of the number is 2. And then the square root of the run part, which is the number under the x, which is just a 1, would be 2 over 1. So the slope must be plus and minus because there's two asymptotes, plus or minus 2 then. Okay, so let's take a look at our formula. X1 or x2 minus x1 equals, or times m. So I'm going to put the m in the front. Let's put m in the front. Sorry, slope times that is equal to y2 minus y1. So my slope is plus or minus 2, x plus 1, that's where the center is, equals y plus 2. So that would be the equation of the asymptotes. And you might be asked to draw this. You'd have to know all the points on that, but I'm not going to draw that right now. And let's just do one last question on this question. Sorry, so not to go too crazy here, but let's find the foci. Let's find where the foci are. Okay, so the first thing I would want to just make note of is the hyperbola has a positive x value, which means it must open left and right. And I know the center is, what do we say the center was? -1, -2. So it's -1, -2. So notice that the transverse axis would run that way. And if you extended it past there, somewhere on that transverse axis, you're going to find your foci. And the distance from here to there is C, and the distance from here to here is C. So what I know is going to be the same height, so I know it's got to be a -2 on the end for both foci. And so now I was going to find out my C value here. So for the hyperbola, a squared plus b squared is equal to c squared. So I have 1 plus 4 is equal to c squared, which means c squared is equal to 5, which means c is equal to plus or minus the root of 5. So I started, my center starts at -1. So -1 go left, negative root 5. And then start at -1 and go right, root 5. So there would be my foci then. Okay, so I think that's good enough for today, just to finish off the chapter. I think we'll talk about our test on Tuesday, but I think it looks like probably Thursday would be a good day for the test. Okay, so I will say goodbye and wish you all well in your future plans.